8.5, Graphing Trig Functions. Well, in this lesson, we're going to look at how you would graph a sine, cosine, or tangent function, or their reciprocals, on a coordinate x and y plane. So if we're looking at it, instead of looking at it on the unit circle where we've been looking at sine, cosine, and tangent recently, we're going to look at it if you were to graph it. But there are some vocabulary terms we need to talk about. The amplitude, well, if you're in physics, you've talked about how amplitude is the height of the wave. Well, that's kind of what this is. It's the same thing. We're even talking about what a sine graph looks like, and you're going to have to go from the middle to the top, and that's the amplitude. It's also, the way described in this definition is from the highest point to the lowest point, it is half that distance between there. So, sine and cosine are the only two that have an amplitude that we're going to talk about. The others don't really have one at all. There's going to be a stretch, like tangent graph is going to, well, let's just give you a quick little preview of these graphs. A tangent, here's a sine graph, and it's a sine wave, which is what we call it. I guess I should point where you can see it. Here's a sine graph, and the cosine graph looks the same. It just starts at a different section, or it's shifted over is another way to consider it. And a tangent graph, well, if you remember on the unit circle, tangent was undefined at 90 degrees, which is pi over 2. So a tangent graph is undefined, has vertical asymptote there, and every odd pi over 2. Well, then it just keeps repeating and keeps repeating, just like the sine graph just keeps going and going and going and going, and the cosine graph does the same thing. It just keeps going and going and going, and they look the same, they're just shifted over from each other. So let me clear that off. Well, a tangent graph has a stretch. Like normally, you go over a certain amount, which, if you remember, tangent was 1 at pi over 4, so this is actually over pi over 4, halfway between 0 and pi over 2, and it goes up 1. Well, when it has a stretch, and we'll make up a vocabulary term for that in a minute that we'll call the ones, just to show you that, okay, what is it, instead of 1, where did it stretch to? And so that was the next vocabulary term, was stretch, which is just a vertical stretch. And then period is how long it takes to get from one cycle until it starts that one over again. So for sine graph, it is 2 pi was the period. And same thing on a cosine graph. Top, go to the bottom. Oops, didn't mean to switch. Top, go to the bottom, get back to the top again at 2 pi. Well, tangent went from negative pi over 2 to positive pi over 2. Or from, that would be the same thing if you went from 0 to pi. So from 0 until pi, then it is 1 period. So sine has a period of 2 pi, cosine has a period of 2 pi, but tangent has a period of 1. And then when we start moving translating these graphs to the left or right, which we've done with other shapes, that is a horizontal translation. That's called the phase shift. And a vertical shift switches the graph up and down. So now let's talk about these graphs. Let me clear this screen off again, and let's just talk about sine, and then we're going to talk about what its reciprocal function looks like. So, like I said, this graph actually keeps going forever. You keep going that way forever and that way forever. Ignore the other graph there. That's what a sine graph does. It just starts, we start drawing it at 0, because if you remember, sine of 0 at 0 degrees on the unit circle, sine was 0. Well, at pi, sine was 0, and at 2 pi, sine was 0. At pi over 2, on the unit circle, sine was all the way up at 1. And that was the highest a sine graph ever goes. It goes up to 1, back to 0, down to negative 1, up, back to 0, up to 1, and it just keeps repeating. Well, cosine at 0, on the unit circle, cosine, when we had cosine of 0, if you look at 0 degrees, cosine was 1. We were over 1, sorry. And then at pi, cosine was negative 1. And at pi over 2, cosine was 0. At 3 pi over 2 on our unit circle, cosine was 0. And then back at 2 pi, cosine was the same thing as it was at 0, which was back at 1. So, the shapes are the same. We just have to identify where we start drawing it. Like I said, the graph goes on and on forever, but we start drawing it normally at 0. And for sine, you start at 0. Cosine, you start at 1. A nifty little trick that helps some people remember it is if you can remember snow cone. Snow cone without the W. That's right. Snow cone. And the reason I show you that is, if you look, we have a little trick here. Sine, we start drawing it at 0. Cosine, we start drawing it at 1. So that's kind of a way to help you remember them, but it's not a surefire way if you can't spell snow cone incorrectly. Now, let's talk about transformations. When you see, just like when you remember when we talked about functions, f of x equals whatever our function was. If we had a times x minus, I'll say bx minus c, and then plus d. Well, hopefully you remember that this number was the vertical stretch. Well, that's the same thing. That's the amplitude. That's going to how tall this wave gets here in the middle. And then c divided by b was our phase shift, and a minus goes to the right. And d was the vertical shift. And those are all terms that we're going to cover. So the phase shift was c divided by b, and the vertical shift was d. The only thing we have to worry about now that's new for this unit is the period, how long it takes for the cycle to restart. Well, normally it's 2 pi, but it all depends on what this b term is. 2 pi divided by b will tell you how long it takes to complete one whole cycle. So, for an example, when we look at this one, I see a is 4, b is 2, c is pi, because the formula is minus c. So c is pi, and d is 5. So that tells me the amplitude, this graph, if we were to graph, it's going to have a vertical stretch of 4. So the amplitude is 4. We don't worry about a negative just changes whether it reflects or not. So that's why it has the absolute value on here. So all we worry about is what that number is. That number is 4, so it's going to stretch vertically 4. And then a normal period is 2 pi, but 2 pi divided by b, which is 2, is just pi. That means it's going to take from 0 to pi to make one full cycle if it were starting at 0. But this one, if we take c divided by b, it's going to be shifted to the right, c over b, which is pi over 2. So that means instead of starting at 0, we go to pi over 2, and that's like the new y, where the y-axis would be, and we start drawing it there. And then the vertical shift was d, so this one went up 5. Now, that's what a sine graph would look like, and that's talking about the transformations. Well, the stretches and the shifts are going to be the same, or all of these terms are the same for sine, cosecant, which is the reciprocal, and cosine and secant. But I haven't shown you what the graph of secant or cosecant looks like, so let's talk about these graphs for a second. Well, if you remember, cosecant is the reciprocal of sine. So let's take a number, like if I take the reciprocal of 0, well, 0 divided by a number, or usually 1, is when you make a number into a fraction, you divide by 1. Well, 0 divided by 1 was 0, but if I take the reciprocal of that, which is just flipping which one's in the numerator and which one's in the denominator, you get 1 divided by 0. So cosecant is going to be undefined whenever sine was 0, which would be at 0 and at pi. Drawing vertical asymptotes there. Those are my imaginary vertical lines. So all of that is undefined. Then we'll write it halfway in between at 1. Sine was at 1, and the reciprocal of 1, if you flip that over, is still 1. So cosecant would be 1. Well, any other number that's smaller, when you take a smaller number, like a number like 0.5, like 1/2, if you flip it over, it's now a bigger number. So it's actually going to be up here, and then it comes down and touches, and then goes back up again. And then it does the same thing at this one. It comes down, or it's down here, comes up. These are all negative values. They go back down again. And then it just keeps repeating that. So sine is continuous everywhere, but cosecant has vertical asymptotes. And the same thing on cosine. So if I switch colors this one, whenever you see a value of 0, that's where your vertical asymptote would be, because dividing by the reciprocal would divide by 0, so it's undefined. And here it's -1, and so we come up to -1 and then go back down. We can't touch our vertical asymptote, so we have to get near these asymptotes. And this one, same thing here. So if I'm ever going to draw a reciprocal function for like secant or cosecant, I'm always going to lightly sketch the original sine and cosine graph, so I know, because otherwise whoops, that's supposed to be C. Otherwise, I don't know where my vertical asymptotes are. I can't do that. I don't know that off the top of my head. I can't do it from memory. Well, tangent, the reciprocal of tangent is cotangent. So let's talk about reciprocals now. The reciprocal of 0 is undefined, so cotangent is going to have a vertical asymptote at 0. And this graph was also, let me draw it in blue. The sine graph, the tangent graph also did the same thing and kept going here. It just keeps repeating. Whoops, it would have come along here and then it goes closer to that vertical asymptote and then goes up forever. Well, if we talk about reciprocals, we said this would be an asymptote. This would be an asymptote. And same thing here at negative pi. Those are all asymptotes for the reciprocal of tangent. And an undefined, if you look at undefined, that was dividing by 0, so the reciprocal would be 0. So you're going to have a 0 here and a 0 here. And then think of, this is negative 1. Whoops. The reciprocal of negative 1 is still negative 1. This value over here should have been at 1, and so the reciprocal of 1 was 1. So it's actually, oops. Sorry about that. So the reciprocal of tangent, which is a cotangent graph, looks like a negative tangent graph shifted sideways. So they'll make more sense when we start practicing these on the rest of the examples. So let's move on, because that should have been all we had on the front. So let's talk about transformations of tangent. Well, it's pretty much the same thing except for the period. The number in front is our amplitude, so we look at how much that stretches it, and it's stretched by a factor of whatever that number was. Don't worry about the negative, because the negative just flips it upside down or not. The period for tangent only had a period of pi. So to find the period, we would take pi divided by b. And b was the coefficient with the x that's inside there. And c still, where the phase shift is still c divided by b like we've done before, and the vertical shift is still d like we've done before. So looking at this example that we have here for us, the stretch would be 3, since there was a 3 in front. The period would be pi divided by 2. No, sorry, not that pi, just pi divided by 2. Pi divided by 2, I'm mixing up. This pi is actually for the phase shift, which is also pi over 2, which means this graph is going to, and it's positive pi over 2, because we always want a minus. You can take the, if it's a minus, you use a positive. That means this graph shifted to the right, pi over 2. We have to know right or left on our assignment. And it's a minus 3, so it shifts down 3. So, now that we've talked about those, let's actually practice graphing them, because you're going to have to get used to seeing what the graph would look like. So for this one, I know it is stretched by a factor of 2, because of that number right there. The negative just means it's flipped upside down. So I know there is a vertical reflection, or reflected over the x-axis. The period of tangent is, you're going to need to refer back to these a lot, so okay, I'm going to write this off. This was 2. The period is pi divided whatever b was, so pi divided by 1/2. So pi divided by 1/2 is the same thing as when you're dividing by a fraction. You keep the numerator, change it to times, and flip the other one. 2 over 1 is just 2. So the period is 2 pi. So that means it's going to be a wider graph. So the period, normally the period was, we could draw it from, in 1 pi we could draw one whole tangent graph, one whole tangent curve. Well, now we have to take all the way to 2 pi before we can get a whole tangent graph. And for the phase shift, we're going to take c divided by b. So I got another fraction, and I'm going to erase this stuff for you real fast. Oh, that's faster. So if I take pi over 2 and divide by 1/2, keep it, change it, flip it, that becomes times, and that becomes 2 over 1. So the phase shift is just pi. That's a pi symbol, if you can't read my handwriting. And then the vertical shift, there's not a vertical shift because there's no number at the end. Oh, and by the way, this was a minus, so it went right pi. So the phase shift was 0. So it does not shift, the vertical shift was 0, not phase shift. The vertical shift was 0, so it does. That means the x-axis is still like our center of our graph. We're not shifting up or down. Now the phase shift was right pi, so that means all the way over here at pi, this is now where I'm going to pretend the y-axis was. So just like we had a y-axis before, we're going to make that the new y-axis. So tangent graph, if you remember tangent, we'll go back and we'll look at it for a second. Did I hopefully have it all cleared off? But no. Tangent at the y-axis was at 0. So, oops, let me turn the page. This tangent graph at the y-axis, I'm going to draw the graph in. I'll go black. So this is now the 0. That's the start of our tangent. And going back to the tangent, let's talk about where the asymptote was originally. The asymptote was pi over 2. So we had from negative pi over 2 to positive pi over 2 was our period. Well, ours has to stretch that. Ours had a phase shift. Well, with a phase shift moved us over, but the period was 2 pi. So it's not going to be back at 0 again until 2 pi later. So I made a mistake. I had a typo and I was trying to fix it, and it shut down my board completely. So I'm sorry about that. So let me get back to where I was and fix the window again. Did it get my second page, or did it lose the second page? I lost the second page completely. Well, I'm going to pause this video and get everything ready, and I'll be back. Okay, so I tried to clean up a little when I rewrote everything. So I noticed my 3 pi was not showing up on the screen, so you might not have seen that at all. So our period went from pi to 3 pi, because that was a period of 2 pi, which is what we said the period was. And we were at 0. And halfway between 0 and 0, that is where our vertical asymptote is. So I don't remember what I said now before I truncated the video and cut off some of them, or I made a mistake and had to fix my mistake. So halfway between 1 pi and 3 pi is 2 pi, and that's where your vertical asymptote will be. Because if we look back at the tangent graph, halfway between 0 and the next 0, which was pi over 2, that was where our vertical asymptote was. And halfway between 0 and the pi over 2 was where our 1 was, how far up we went. So our graph, halfway between our 1 and 2 pi, halfway between our 0 and our vertical asymptote, is where we would normally go up 1. But we're going to go up 2. It's stretched by a factor of 2. I'll have to shred it. Yeah. So we would go up 2 if it were positive. But remember, this had a negative. So that negative means this is flipped upside down completely. So this is reflected over the x-axis, or non-math term is flipped. So instead of going up 2, it actually goes down 2. So that's here. But before that, half between pi and back to 2 pi. So if our period was 2 pi, if I go from pi, here's 1 pi back, 2 pi, here's our next period. So this is the other 0. Halfway in between would be a vertical asymptote. And this graph would be going from, this one was up at 2. That one was at negative 2. So it does this kind of looks like the tangent graph, but going the other direction. So there's what it looks like. I could have sketched a regular tangent to show you first. I might do that on the next one. I might sketch a sine graph before we do any of the movements, just so you can see what we're comparing it to the original without having to go back and forth to the front page every single time. So let's move on to the next one. Let's talk about, well, I'm going to draw real lightly, and I'll draw it in yellow, so it's just kind of barely there. A sine graph goes from 0, pi, and 2 pi. We're at 0. Halfway in between, we're up at 1. Halfway in between, we're down at negative 1. There's what one period looks like, and like I said, it just keeps doing that over and over. So if you want to go halfway in between, we're down. Halfway in between, we're up. There's what it would look like for the whole graph. It just keeps going forever, and doing that same pattern. But yeah, connected right here. Not ignore my scratch. Oops, my eraser's a little too big. So okay, so there's what it would look like. We're only going to look at one period, so really I'm going to take off. We don't need, I wanted to show you that it keeps going, but we don't need all that extra stuff. So I'm going to take off everything before and after 0 to 2 pi is all we're looking at. 0 to 2 pi, which was here and here. That's what it would be with no stretches and no transformations. So let's talk about the amplitude, the stretch in front. There's no number, so it's a 1 or no stretch at all. the period is, for tangent period was pi divided by b, but for sine period is 2 pi divided by b. Hopefully I'm not cutting off my screen. I don't remember where my boundaries are. Oh, yeah, it was cutting off, so we'll move it a little bit over. So 2 pi divided by b, so that'd be 2 pi divided by 2, so the period is pi. So tangent, when the period, that stretched it, this period, we're going to go from 0 until pi will be one complete cycle. So where it's cutting, it's squishing this one, it's making it more narrow. The phase shift is c divided by b, so that is pi over 2, and it's a minus again, so it went to the right. Did all of them go to the right? So we're going right pi over 2. And the vertical shift, there's not a number at the end, so you could say 0, or some of the answer choices would say not applicable. Either answer is the same. So D equals 0 was, if you wanted to, because on the assignment I think we asked what's A, what's B, what's C, what's D. So sometimes we'll just say D is 0 in this one. Phase shift is not C. Phase shift is C divided by B, so you have to know the fractions. But now let's talk about how that graph compares to what we did originally. Yellow was the original graph. We have to shift right pi over 2. So here's my new y-axis. I'm going to make it solid instead of dotted, just so we're taking this y-axis right here and moving it over. Everything moved right pi over 2. Then the period went from that distance 1 pi whole unit. So pi over 2, so 0 to pi was 1 whole period, was what the period would be if we started at 0. But we're shifting everything right pi over 2, so our periods, one full period would go from pi over 2 to 3 pi over 2. That is the same as pi. If you need to know that, if you want to do a little mental math here, or maybe write it down, 3 pi over 2 and minus pi over 2, we didn't start at 0. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is just pi. That was one whole period. Our period had to be pi, so don't worry about that. That's just showing you that that was equal to pi. It does not move up or down any, so we're still using the x-axis as our middle of our graph. And I'm going to draw this new sine graph in blue so that you don't... The red period tells me where to start and stop. Sine starts at 0, so I start at 0 and I end at 0. Halfway in between, I'm at 0. And then halfway in between that, we would go up 1. Make sure our amplitude is 1, so it still goes up 1. So halfway between pi over 2 and pi is right there. Let's go away. There we go. And halfway between pi and 3 pi over 2 is here. And so there's what our graph is squishier. It's narrower when the period is smaller than 2 pi. So if it's bigger than 2 pi, it would stretch it out. But if it's smaller than 2 pi, it cut it in half in this case. Well, let's talk about a cosine graph. I'll make sure I didn't miss it. Okay, I looked good on that. I did everything right on that one. Didn't have to erase and start over. So let me move this up a little. So a cosine graph, let me draw in yellow what the cosine graph would have looked like. It would have started at 1, and at 2 pi, it would be back at 1. Halfway in between, it's at -1. Whoops, -1 is here, not down there. Let me erase that so I don't mess you up. And then halfway in between those, it's at 0. So here's what a cosine graph. It's just a shifted over version of a sine graph. Well, on this problem, let's talk about... I need to make sure that my graphs... Okay. Where are my... Let's center the graph a little. Or my box. This one, the amplitude is 4. The period is 2 pi divided by 1/2. 2 pi divided by 1/2, which is the same thing as 2 pi times 2, which is 4 pi. So this one's stretched out. It's going to take a long time to get back to where it starts. The phase shift is going to go to the right, and pi over 2 divided by 1/2 is the same thing as pi over 2 times 2. And that is just pi, so it shifts to the right pi. And the vertical shift, this one shifts up 2 because of the plus 2 at the end. So, shifting up 2 means this is our new x-axis. And shifting to the right pi means this is our new y-axis. So there's the new x and y axis that we're going to use. And I'm going to go from 0, well, from my new 0 until 4 pi. So here's 1 pi, 2 pi, 3 pi, 4 pi. And if you think we're starting at 1 to go 4 more, this will be one full cycle to get all the way to here. So you don't have to draw that line. I'm just kind of making it for reference points. And the amplitude is 4. So normally on a cosine graph, we would start at 1. So like here we started at 1, but we are moving here, and now we have to go up, or have to stretch it. We have to go up 4 instead of up 1. So 1, 2, 3, 4. Here's the top. So there and there we're at the top. Halfway between 1 pi and 5 pi, which would be 3 pi, we're going to have to go down 4. So from our 0, remember this is the new y-axis, the new 0 x-axis, sorry, down 1, 2, 3, 4, we're here. Halfway between those is where we're going to be on the x-axis. So between 1 pi and 3 pi is at 2 pi. So we do this. Halfway between 3 pi and 5 pi, we'll be back at 0 again. And then it actually keeps going, but we're just drawing one little piece, one period only. And that is the entire graph that we need on that one. There's a lot of practice on this because we want you to get comfortable with knowing, does the bigger number in front make it look taller and smaller? Does the bigger number, does the b make it seem to stretch or compress? And once you start doing enough of these practicing, you will get a little more comfortable with them. That's everything you need for this assignment. So good luck to you.